Aufnahme starten. Stream starten. Ja, Stereo. Okay, and the Zoom, right? The Zoom. Start site, noise meeting, and yes, einladen.
Recording in progress.
Zulassen.ปุ๊บนี่ครับนี่พยายามจะไม่ลืมโอเคand Zoom right anybody Zoom oh okay Zoom we have to switch from to show and this one too okay no this one 605 copy this one Zoom meeting is So good morning, everybody. I hope that you can hear me, right? In either in Zoom, in both Zoom and YouTube stream. Okay, let's talk about the first person. ก่อนครับก่อนเงินบำรุงครับอยู่ไหมครับได้ยินนะครับก่อนได้ยินนะครับโอเคเรียบร้อยครับ fine I can see you the second person ปัณณธรครับคนนี้ใช่ไหมเอ่ยปัณณธรเสื้อขาวใส่หูฟังใช่ไหมครับโอเค fine thank you and the third student วชิรวิทย์ครับวชิรวิทย์เรียบร้อยครับโอเคครับfourth สุภวิทย์ครับสุภวิทย์ที่เป็นเสื้อชมพูเนี่ยครับเสื้อสวนเนี่ยนะครับแล้วก็มีดวงดาวอยู่ข้างหลังใช่ไหมครับเพราะว่าชื่อคุณไม่ขึ้นครับโอเคขึ้นแล้วชื่อขึ้นแล้วเรียบร้อยครับสุภวิทย์นะครับ the fifth person นัทวินครับนัทวินคือชื่อขึ้นแล้วนะครับเรียบร้อยโอเค fine moment okay. So the next person is number 6 right เฮ้ยนัทวินไปแล้ว number 6กฤษภพครับกฤษภพอยู่ไหมครับกฤษภพโอเค fine กฤษภพครับseventh ภวิทย์ครับภวิทย์ right am I correctly pronounce do I correctly pronounce your name นะภวิทย์นะใช่ไหมครับโอเคภวิทย์ and the next person พีรทัศน์ครับพีรทัศน์โอเค fine ชื่อขึ้นแล้วนะครับ the ninth person กฎชวงศ์วัฒน์ครับกฎชวงศ์วัฒน์โอเคครับเห็นเพดานเสยๆนะครับเห็นผมหน้าผากนิดนึงโอเค fine the 10 student ภวัตครับภวัตตรงม่านเหลืองนี่ใช่ไหมครับม่านเหลืองนะโอเคชื่อขึ้นแล้วนะครับเรียบร้อยนะครับwith 11 with คือคนโอเค fine นะครับธนากรเสื้อขาวใช่ไหมครับโอเคครับผม15กิตวัฒน์ครับสวัสดีครับ15กิติวัฒน์ sorry I didn't pronounce your name properly อยู่ตรงไหนครับคนที่มีแสงลงหน้าข้างหลังสีเหลืองใช่ไหมครับคือเราพูดถึงคนที่เท่าไหร่กันครับเนี่ยผมถึงคนที่เท่าไหร่นะครับฮัลโหลผมพูดถึงคนที่เท่าไหร่แล้วนะครับวิชไปแล้วใช่ไหมธนากรก็ไปแล้วใช่ไหมครับธนากรดิผมถึงธนากรใช่ไหมครับฮัลโหล anybody can hear me ธนากรไปแล้วตรงนี้ไปแล้วนะ50กิติวัฒน์ก็ไปแล้วใช่ไหมครับกิติวัฒน์ใช้คนที่ซานฟรานซิสโกนี่หรือเปล่าครับ15กิติวัฒน์ใช่ไหมครับคนนี้ใช่ไหมครับ15โอเคกิติวัฒน์ซานฟรานซิสโกโอเค your name has already appeared 16ทิรุธครับทิรุธปาฏิหาริย์ยังไม่ต้องนะครับทิรุธก่อนครับอ๋อ13ปาฏิหาริย์เหรอหรือผมยังไม่ได้เรียกใช่ไหม sorry ผมลืมคนไปหมดแล้วนะครับปาฏิหาริย์ครับปาฏิหาริย์คือตรงซานฟรานซิสโกนี่นะครับสะพานข้างหลังนี่นะครับ ชื่อคุณไม่ขึ้นนะครับผมก็งงเลยนะครับปาฏิหาริย์ไปแล้วธนาธรครับธนาธรอ่าโอเคธนาธรชื่อขึ้นด้วยนะครับฝ่าย thank you very much สวัสดีครับกิตติวัฒน์ครับกิตติวัฒน์โอเคซานฟรานซิสโกฝ่าย and 16ที่รุธครับที่รุธ are you there ที่รุธ or you have any internet connection problemที่รุธ hello 16 are you there 16 if not then I'm going to write down absent for you 16 still the number 16ทิรุธหอมชื่นครับทิรุธ any idea about that ทิรุธหรือเปล่าอันนี้ไม่ใช่นี่พฤตินันเนี่ยยังนะครับ we are still talking about still the number 16 are you there ทิรุธ if not then I will mark you as the absent status absent okay so let's go to the next person 17พฤตินันครับพฤตินันจอแล้วนะครับพฤตินันจอละพฤตินันcan you hear me ที่ YouTube เปิดไว้ให้แล้วนะครับเปิดไว้ก่อนแล้วนะครับหรือว่าเข้าไปพิมพ์ที่ YouTube ก็ได้นะครับโอเคไหมพฤตินันเมื่อกี้เห็นแวบๆว่าไงเอ่ยครับพฤตินันโอเคพฤตินันฉากสีเหลืองนะครับฝ่าย thank you very much สวัสดีครับ good morning the next person 18ปานทัศน์ครับปานทัศน์ปานทัศน์เห็นเรียบร้อยครับ thank you very much so who is that นนทกร19นนทกรสวัสดีครับโอเคครับนี่คนนี้มุมเดิมตลอดนะครับโอเคเยี่ยมมากครับทำให้ผมจำง่ายนะครับ20วาลินทอนวลินทที่เป็นโอเคยืนหน้าเข้ามาตรงนี้นะครับใกล้ๆนะครับแต่ชื่อทำไมชื่อคุณไม่ขึ้นนะผมก็ใช่วลินทรจริงๆนะอะไรนะครับโอเค60520 thank you very much 21 ลาวิพลครับลาวิพลจำได้เลยนะครับโอเคมากฉากเหมือนเดิมเป๊ะ thank you very much good morning สวัสดีครับthe 22nd วาลินครับวาลินใช่ไหมครับคนนี้วาลินโอเคชื่อขึ้นเรียบร้อยครับ thank you very much the last person พระสิทธิ์ครับพระสิทธิ์โอเคสวัสดีครับสวัสดีครับokay I would like to mention that 16ที่รุธ is
มาแล้วครับ
อยู่ตรงไหนครับ
เนี่ยครับแป๊บนึง
16ครับเชิญครับ605มีข้อดีคือคุณไม่เสียเวลาเซตอัพเลยนะ604เปิดมาเนี่ยโหอินเทอร์เน็ตมหาวิทยาลัยเซตอันนู้นอันนี้ลำโพงไม่ดังครับเสียเวลานานมาก605น่าจะไปได้16 I'm waiting for ขอชื่อขึ้นนิดนึงได้ไหมทำไมชื่อไม่ขึ้นเลย16จริงๆนะแต่ว่ามุมกล้องนี้ไม่เคยเจอใครคุณน่าจะเป็นหมายเลข16จริงๆครับชื่อไม่ยอมขึ้นตรงนี้นะครับน่าจะใช่แล้วครับโอเคไหม16 I'm going to change your status from absent to be present again right you can note that there will be only few homeworks okay for your formative score before the midterm exam. Okay, so it's really worth. Okay, please don't lose it. Unlike the former or the previous year students, we have a lot of homeworks before we enter the midterm exams. Okay, so they work much harder than you, and we didn't take into account the class attendance score at all. Okay, before we start the lecture, okay, may I go to the toilet for a while นะครับขออนุญาตเข้าห้องน้ำแป๊บหนึ่งครับเพื่อจะยังไม่ได้เบรกจากห้อง604นะครับผมย้ายคุณมาที่จอนี้แล้วนะครับเพื่อว่าจะได้ไม่กีดขวางนะครับระหว่างทำการเรียนครับโอ้ Okay, now please move the microphones be ready. Everything should be fine. Okay, and now no one is there. ผมขออนุญาตเข้าห้องน้ำแป๊บนึงนะครับ Okay, we arrive at we arrive at the end of the problem related to I didn't change it. Related to the magnetic field or magnetic force, right? In this example in Zoom, and for the people in YouTube, I think no one is in YouTube. Okay. Okay, we arrive at this example, and we still have one sub problem remaining in this example, okay, which is the story about the electric force, right? So it's the knowledge you may have learned it before in material 4 or material 5. I'm not sure. It would be in the last year for you. It's the force that caused by the electric field. Okay, if you have a shot lying in the in the area of electric field, you will get the force. Okay, and it will be in the same direction as the electric field force, right? If you have the positive charge on that, but if you have the negative charge, it's going to be in the opposite way, right? That's quite similar to the magnetic force here. Okay, compare the former results. The magnetic force we have calculated on Wednesday to the electric force if there were an electric field with a magnitude equal to 1.5 times 10 this is to the power of 2 and at that location. So we have to go back to วันนี้คุณครูจอยเข้าด้วยใช่ไหมครับ so we have to go back to the to the to the to the whiteboard. stop อันนี้ก่อนครับโอ้ no 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 ผิดนะครับ stop and I have to switch session. Okay. So now we are at the whiteboard. Is the problem we considered in M605. And today we are going to have an assignment, okay, or homework. And that homework is really the problem here you will see, or the same problem as you have seen on Wednesday, because I have introduced you how to apply the FQVB formula already, right? Please choose any problem that contains the question of direction and also the absolute weight or the magnitude of the force, okay, the magnetic field force. So assignment of today is is that you have to find any problem, any question related to this formula, okay, if Q V cross B, right, and F, which is the scalar version or magnitude of this vector, is absolute Q, and V B psi theta. Okay, theta is the angle between vector V and vector B. So let's talk about the remaining sub question in this problem, in this example. If you have two plates, okay, this is the positive, right, positive side, and this is negative side, negative plate of, there will be electric field right from this one, and like this. And if you have proton, just leave it like here, okay, it's plus, and there will be force acting on this this way. So of course, it's like you have seen at the beginning of this slide, the electric field start from the positive area to the negative, and there will be force which is F. Let's say it's Fe, okay, denoted by the subscript E, and Fe is equal to Q, okay, times E. Actually, it's absolute Q if you want to see it properly or exactly. It should be absolute Q. Oh no, yeah, it should be Q simply. No absolute. Okay, it can be negative if you consider the negative charge. Okay, so it's better to not have the absolute value. Okay, simply Q as M604. Okay, Q is the amount of charge for this particle, and E is the strength of electric field, okay, which is in Newton per Coulomb. Okay, in this scenario, they say the electric field is 1.5 times 10 less 2 power of 2, right? 10 less 2. So it's actually 150 Newton per Coulomb. Okay, the strength of the electric field on these two plates, and you just leave it into this expression. But let's remind the value of the proton charge, and they say the Q of proton, Q proton is 1.6 times 10 raised negative 19, right? For simplicity, Coulomb. We assume that actually it's not 1.6. There are some more numbers. อันนี้ที่แก้ศูนย์นะครับโอ้หมายความว่าอะไรเนี่ยทลิตนี่อ๋อรุ่นพี่คุณครับผมงงมากใช่ปะโอ้ขอไปนะครับรุ่นพี่คุณฟิสิกส์นะครับเพิ่งตามมาส่งการบ้านนะครับผมไม่อยากให้เกิดขึ้นกับคุณนะเห็นไหมครับมันพลุงพลังเนี่ยแล้วไม่รู้เขาผ่านไปแล้วหรือยังอยู่กับรุ่นปีเดียวชั้นปีเดียวกับคุณอยู่ผมก็ไม่ทราบได้นะครับโอเคไหมมันจะเกิดปัญหาอย่างเงี้ยนะครับโอเคไหมplease try to not have any problem when something happen like this. It's difficult to handle, and it's difficult also for me to do everything on time. Okay นะครับระหว่างที่สอนคุณเขาก็ส่งมาโอเคเชิญครับว่าครับลิงก์ YouTube ได้ครับมันเจ๊งใช่ไหมครับเข้าไม่ได้ใช่ไหมครับเดี๋ยวได้ครับเดี๋ยวanything wrong ได้ครับเดี๋ยวส่งลิงก์ YouTube ให้นะครับผมไม่ได้ส่งให้ใช่ไหมผมส่งให้แต่ที่แรกเลยดิห้อง605เลยoh no this this one right yeah YouTube here this one อันนี้นะครับน่าจะเป็นอันนี้ keyboard number 2 เรียนอาจารย์ครับลงนามภายในสัปดาห์หน้านะคะอาจารย์อ๋อได้ครับเดี๋ยวสอนอยู่ครับตอนนี้คุณครูโรสนะครับคุณครูวิมลรัตน์คุณครับ605นะผมส่งลิงก์นะครับโอเค it's already there for M605 I send the link to you already alright ขออนุญาตต่อบนกระดานนะครับokay let me continue our story on the whiteboard okay what else we are going to compute right the electric force okay the force caused by electric field okay let's go ahead of course we have to deal with this formula. It's quite simple. You can see FMA, okay, it's mechanical setup, okay, it's Newtonian physics, right? F equal MA, and F in magnetic is QVB sine theta, right? In F in electric field is QE, okay, it's quite simple. It's only a product of Q and E. So now let's substitute the value of both variables. Q is the charge of the proton, right? It's 1.6 times 10 raised to the power of negative 19 coulomb. Okay, whether you will write down the charge unit together with this number or not, it's fine. Okay, it's good. Okay, if you write down the unit because to prevent the error, okay, that can happen in the substitution of several variables. Okay, and the next one is the electric field, right? And they have provided in this value is 150 Newton per coulomb, right? And you can see that if you leave the units in that expression, you can see what is going on. What should the final unit of the outcome be, right? You can see that coulomb and coulomb will cancel each other, and the remaining unit is going to be only Newton, right? So you put 150 into the calculator, okay, with together with number 1.6, okay. But if you don't use the electronic calculator, I think the number the effort in this calculation is not beyond your ability in high school, right? In Matheum 6, right? Let me check the health in YouTube. Okay, and it's going to be 2.4, okay, 2.4 2.4 times 10 raised to the power of negative 17, and the unit is Newton. Okay, simply like that. Okay, and that's the result. Okay, so the assignment or the homework for today lecture is something about this formula. Okay, you know, you have to be able to find the direction and the magnitude. Okay, but this one is beyond that formula. Okay, it's just related to the magnetic force. All right. I hope that you have ever seen the you have got the chance to find or determine the electric force before, right? This problem just remind you to calculate the electric force again. Now we are back to the lecture notes. Share นะครับ share หน้าจอ this one and in YouTube yeah right yep and okay we now finish this example okay in Zoom and we arrive at another we arrive at the next example mouse เดี๋ยวนะครับขอเซตเมาส์หน้าจอนิดนึงมันวิ่งเขวไม่เขวนะครับwhat happened เพื่อความสมูทนะครับOkay. For the people in YouTube, we arrive at the next example, which again, okay, talks about proton movement or motion. There is a proton again. A proton, okay, you can somehow remember the charge value of proton. You can remember somehow the mass of the proton, right, from the previous example. But the speed or the velocity of the proton can vary, okay, in different situations. In this example, is taken from the book number 2 and example 19.2. In that book, the proton moves at 8 million. You can see 8 times 10 raised to number of 6 10 with the power of 6 meter per second along the x-axis, okay, and it later enters a region where we have magnetic field of magnitude 2.5 Tesla. It's quite strong, okay. It's not on the scale of micro, right, mu. This is on the scale of Tesla exactly, so it's quite strong. Directed at an angle of 60 degrees from the x-axis, and both components lie on the xy plane, okay, in the xy plane. If you don't completely understand the text, okay, it's better to take a look at this figure, okay, in figure number 11, okay. Of course, the proton, okay, proton is denoted by plus and e. You can see here, right? What is the reason why they use the letter e simply like that? Okay, you know that e is the charge value of electron, right? Because e stands for electron. But why do they leave the letter e here also for the proton? ทำไมเขาใช้ e แทนค่าประจุสำหรับโปรตอนด้วยทำไมครับ Any idea about that? So should ช่วยเปิดไมค์ตอบหน่อยนะครับหรือว่าคนอยู่ YouTube ก็เปิดพิมพ์ text มาให้รับทราบหน่อยก็ได้นะครับหรือว่าอะไรทางไหนก็ได้พิมพ์ทางไลน์ก็ได้โอเคไหมครับทำไมตอนนี้คนตอบผมเยอะจังเลยนะครับโอเคany idea about that มีไหมครับเดี๋ยวผมเปิด text ก่อนเผื่อคุณจะตอบมาทาง text ทำไมเขาใช้ e เลยสำหรับโปรตอนได้ What is the reason why they just leave the variable e for the charge value of of proton? The answer is because proton has the same charge magnitude as the electron, right? So it's acceptable to just not say 1.6 times 10 raised to negative 19. Okay, just simply leave the letter E here. Okay, and just specify the positive nets by placing the positive symbol here, okay, in front of E. Okay, and that's the meaning of 1.6 times 10 raised to the negative 19, okay, coulomb. And the proton moves, right, according to the explanation in that example, moves along the x-axis. Here is the x-axis, right? And on the right we have the y-axis, right? Here, y-axis. And apart from that, apart from the motion of the electron only, we have also the motion. Oh no, not motion. We have magnetic field, okay, or the magnetic flux density directed in this way, okay. It's still on the xy plane, but this direction is made by 60 degree with respect to the x-axis, okay, the red vector. And that's the explanation, okay. And of course, let's move to the question in this example. Find the initial magnitude and direction of the magnetic force on proton, okay, on this particle. Okay, in physics we have to say two things, right? The first one is direction, the second one is magnitude. So let's go back to the whiteboard. Okay, get back to the whiteboard. They said oh, because this is the 3D scenario, right? I have to say to you, this is the x-axis, okay, in Cartesian coordinate, and here is the y-axis, right? X to y, right hand, and the z-axis is along my head this way, okay, and x-axis, okay, straight to you, to the camera, and y-axis straight to the wall here, okay. And they say the proton, okay, let's say this is the proton, now moves to you, okay, along the x-axis. This particle is proton is moving directly to you, and here is still the y-axis, right? But they say that no, there is a magnetic field, okay. They just point. They are magnetic field lines are pointed in this direction, okay, and this direction is made by 60 degree, okay. It's not y-axis, okay. Y-axis is over there. This is direction of the magnetic field, and the angle between magnetic field vector and the x-axis is 60 degree, okay. You understand that? The question in this example is what should the direction of induced magnetic force be? That's the first quantity we have to determine. The second one is the magnitude of that induced magnetic force. Okay, let's talk about the first thing, which is physical way. Okay, it's the direction. So, okay, let me write down write the conclusion again on the whiteboard. Okay, in order to find the direction, you use this formula. It's the vector formula, And for calculating the magnitude of the induced magnetic field, you have to use this formula, the second formula. Okay, I will note it on the whiteboard. This is the formula for direction. Okay, and here is the formula for magnitude. Okay, because in physics, usually we have two things: a direction and magnitude, right? Usually, any quantities in physics have both components. Q. Okay. Let's write down the Cartesian coordinate on this plane here, which is 2D. Okay. This is the z-axis. This is the y-axis. And x here in the proton is moving along on the x-axis, right? So proton here moving, okay, is moving like this along the x-axis, and there is xy, right? There is a magnetic field pointing in this way, okay, 60 degree from the x-axis. So the magnetic field is going to be somewhere here, okay, and it can be written like this, okay, and this angle is theta equals 60 degree, okay, and they ask for the direction for the induced magnetic field, right? So we have to use this expression. The v1 here is vector. The blue one here is vector v, right? And the red one is the vector b. Okay, it's magnetic flux density vector, or simply in high school level, magnetic field vector, right? So that's those are two vectors in order to get the direction of f, okay, vector f, you just start from the first vector v to b, okay, v to b. This is the second vector. V, okay, v, this is v, b, right, b boy. This is v, I don't know, v van, okay, v van. This is b boy. From v van to b boy, okay, and you use your right hand, right? V van to b boy, right? You turn a little bit your four fingers and you get the thumb direction as the output, okay, as the direction of f. Okay, actually it is the direction of the product of these two vectors, but it doesn't matter, because if your q is positive, okay, because we are talking about a proton, right? Q is positive, the outcome of this cross product will be transferred directly to the left hand side, okay, you get the direction of the induced force as well. But if q is electron, is negative, your f is going to be in the opposite way of this cross product result. Could you understand that? พอเข้าใจได้ไหมครับเริ่มจากเวกเตอร์ตัวแรกไปเวกเตอร์ที่2นะ v ไป b โอเคไหมครับไม่ว่าสถานการณ์ใดก็ตามอย่างตัวอย่างนี้คือ v ตรงนี้ b ตรงนี้คุณก็หมุนไป v ไป b ปึ้งนะครับพอหมุนปุ๊บคุณจะรู้ว่าตรงกลางนี้นะครับเป็นจุดเซนเตอร์ในการหมุนนะครับคุณหมุนนิดนึงปุ๊บนะครับก็คุณก็จะได้ทิศของนิ้วโป้งนะครับเป็นทิศของผลลัพธ์ของเวกเตอร์ครอสกันนะครับถ้าเป็นประจุบวกมันก็ f ก็ทิศนี้เลยโอเคครับ f ก็จะขึ้นไปอย่างนี้เลยครับ so that's the way we could determine the direction of the induced magnetic force, okay, and here we have f, okay, vector f induced force like this, okay, because this is the positive charge, okay, it's proton, it's already defined, we get direction, okay. So in order to say, we will say the direction of the induced magnetic force is along the positive z-axis. Okay, we would say that along the positive z-axis, and that's the answer for the direction. Okay, we get that. And now let's move to the second thing we have to determine is which is magnitude. Okay, we have to use this expression f absolute q v b sine theta. By using this, by looking at this figure, you can see that v is here, b is here, right? And what they have provided there is 8 million, I think. It's 8 million, right? 8 ล้านใช่ไหม? Yeah. 8 million meter per second. That's the speed of the proton. Okay. V here is 8 times 10 raised to the power 6 meter per second. And the magnetic field, I think it's quite strong. It's 2 Tesla or something like that, right? Yes, 2.5, sorry. 2.5 Tesla. B here is 2.5 Tesla. Okay, so we will substitute everything into this, right? But we know already three or four variables, including proton charge 1.6 times 10 raised to the negative 19 coulomb. Velocity is 8 million meter per second. Magnetic flux density is 2.5 Tesla, and the angle here is 60 degrees. So it's not beyond your ability right now. So the magnitude of the induced magnetic force is going to be absolute QVB sine theta, right? So it's absolute of what? Of plus, because this is the proton, is 1.6 times 10 raised to negative 19 coulomb, right? The absolute. And the second variable is velocity is 8 million, and 8 times 10 with the power of 6 meter per second, right? In the next variable is Tesla. Okay, sorry, magnetic field. It's 2.5 Tesla, and that's it. And then we have the second one is sine. The last one, sorry, it's sine of theta, which is 60 degree, right? This is 1/2, right? And you put everything into the calculator or by using your hand. Okay, you get something like this. Okay, get something like this. 2.77 2.7710 raised to the power negative again 19 Newton. Okay, which is very, very tiny. Okay, and that's the second property of the induced magnetic force, which is the magnitude, right? It's somehow which is very tiny. And the next question in this problem is ผมอยู่ถูกนะครับอยู่ที่กล้องนะไมค์ขึ้นเรียบร้อยให้อยู่นะครับ Let me check whether the microphone is proper or not for the Zoom people. Okay, it's all right. Yeah, that's the first question we have, which is completed right now. Let's move to the next question in this example. Calculate the proton's initial acceleration. So as you know, in any Newtonian problem, the problem that uses Newton laws. Okay, this is an object with mass m. Okay, let's say if you have a force acting on this object or particle with this amount, okay, and this particle is going to move, right, in the same way as the force that exerted on, and assume that there is no resistivity, no resistant force by air or drag or something like that. So there is only a single force acted on this that acts on to this object only. So this object is going to move right away in the same direction as the force, right? And with the acceleration a, right? And that's why we get the Newton law, like ma, right? And they just ask us if what is the acceleration to the proton in this scenario. So that's the variable a, right, in this formula. So if you want to find a, you just move m to the left hand side. It's going to be f by m, okay, like this. Okay, all right. Now let's do that for this example. Now a is the acceleration and it's equal to f, right? Right away, which is the result here. We have got 2.77 times 10 less s to the less to a negative 19 Newton and divided by m, okay? And if you can remember, the mass of the proton is 1.67, right? And times 10, okay, let me write down somewhere there, right? Mass of proton is 1.67, okay, very close to proton charge or electron charge 1.6, right? This is 1.67 times 10 raised to the negative 27, okay, kilogram. That's the typical unit for the mass, okay. In physics, we are going to use we usually use the SI scale, right? It's on kilogram, okay. It's not as in chemistry, okay. I think you also study chemistry, right? The people in chemistry use the mass scale as gram, right? But it's not for us. We usually use kilogram, okay? Even it's really tiny. So the mass of proton is that number. So we leave it there. 1.67, 10 raised to negative 27 in kilogram, right? Okay, and we get the result as the division. M proton is larger, okay, greater than m of electron, okay, because electron is a smaller particle than the proton. For electron, we have 9.11, right, times 10 with the power of negative 31, right, kilogram. Okay, it's smaller. It's lighter than proton, but we will talk about that later. For us in this scenario, if you put those two numbers into the electronic calculator, where is that? Yeah. Okay, you put it into this one, you get the result, and it's equal to 1659. Okay, 1.659 times 10 raised to the power. It should be positive, right? Because at the denominator we have something more negative. Okay, when you change it to the numerator position, you're gonna get 10 raised to the power of something positive, which is right now is 15. Okay, 15 meter per second square.
like this. Okay, and let's talk about the reality, whether this number is correct or not. In reality, if this is the result we got from the calculation, could you realize that whether it's properly happens in nature มันถูกหรือเปล่า 1.5659 คูณ 10 กำลัง 15 เมตร ต่อวินาทียกกำลัง 2 เนี่ยมันคุณคิดว่าจริงไหมช่วยตอบผมหน่อยนะเปิดไมค์ก็ได้นะโอเคไหมครับมันไม่ได้สิของทุกอย่างมันต้องความเร็วไม่เกินแสงไม่ใช่เหรอความเร็วแสงมันเท่าไหร่นะ3 คูณ 10 กำลัง 8ใช่ไหมครับเอาง่ายๆอันนี้มันเกิน 10 ยกกำลัง 8คุณคิดว่าเป็นไปได้ไหมครับ What do you think whether it can happen in reality Any idea about it 11:50 right we still have 30 minutes left มีคนไหนตอบได้ไหมครับมันเกินหรือเปล่าเนี่ย3 คูณ 10 กำลัง 8ไม่ใช่เหรอความเร็วแสงมันต้อง30 กำลัง3 คูณ 10 กำลัง 8อันนี้มันเกิน 10 กำลัง 8ไปมันได้10 ยกกำลัง 15แล้วมันถูกเหรอถูกหรือไม่ครับอันนี้ What do you think it could be possible because this is the acceleration okay it's not velocity it's acceleration so now let's get back to the next example now we move to the next example get back to the lecture notes where is that sure share the screen this one right share the screen no. Stay my phone
Okay, now we get back to the lecture notes and we have gained here another problem and you can see that they say let the mass of an electron be as I told you 9.11 times 10 raised to the power raised to the power of negative 31 kilogram okay as the typical unit in the SI and calculate the acceleration of electron that moves through the same magnetic field okay as in the previous example and we assume that the electron has the same velocity as the proton in the former setup in the former problem so how could we do that เราจะหาได้ไงครับนี่ so we have to get back to the whiteboard again okay where is it
okay now we return to the whiteboard but now we don't have the proton particle anymore okay it's electron so we need to change okay it's not positive charge it's here negative charge okay negative charge electron and we have to repeat everything okay what is the induced magnetic force direction should be that should be in that should take place in this scenario มีใครตอบได้ไหมครับคุณคิดว่าทิศทางของแรงสนามแม่เหล็กของอันเนี้ยจะต้องเป็นทิศใดเอ่ยครับช่วยหน่อยครับมีคนไหนได้บ้างไหมครับ Any idea about that มีบ้างไหมครับมีคนไหน ช่วยคิดให้ได้หน่อยนะบ้างไหมครับ Any idea about that ทิศของแรงที่เกิดขึ้นกับอนุภาคเมื่อมันเป็นอิเล็กตรอนอ่ะมันจะต้องทิศอย่างไรครับลองดูครับลองดู Any idea you have any idea for that คุณคิดว่ามันจะต้องมีทิศไหนเนี่ยอย่างนี้มันควรจะมีทิศใดดีครับIs there any idea from you well you know that this is the velocity direction right the direction of the electron movement right away to the camera on the x-axis right along the x-axis and the magnetic field is the same okay pointing in the same direction in the same way okay it's still 60 degrees between those two vectors and here okay it's electron to move there okay and of course there will be induced magnetic force right and okay V to B right you use your right hand V to B okay as same as before and the important thing is this is not positive charge okay usually okay we get the induced magnetic field in this direction okay from the right hand rule okay this direction is the result with the assumption that we are considering the positive charge okay but electron is not positive charge okay electron will get the force in the opposite way as the proton okay so the opposite direction to this one okay is this direction okay if we say we have said in this text or in this sentence that the direction of the induced magnetic force is along the positive z-axis right? This is the positive z-axis but for electron it's going to point downward like this so it's no longer positive z-axis anymore it's rather negative z okay negative z-axis so in order to answer okay to say the answer for direction of the induced magnetic force it's going to be it's not a positive z-axis but rather negative okay negative direction and negative z-axis okay for the direction of induced force exerted on the electron okay that's the first thing so let's talk about the induced force okay induced force is 1.6 it's again the same formula absolute Q V B sine theta right so we still use this formula in order to find the magnitude of the induced magnetic force and you leave the charge of electron you know that the electron is not positive you leave it like this it's negative right it's negative 1.6 times 10 to the negative 19 coulomb okay the same value but in the opposite way in opposite side it's negative so but we have the absolute so it's going to return positive as the outcome of this term right in you will still get the same value 2.77 times 10 to the negative 19 but the direction is downward okay it's long negative z-axis and that's the answer for the magnitude okay the same magnitude of force for electron. And let's talk about the acceleration. Okay, if this, of course, proton is heavier than electron, you get this acceleration. But for the second scenario, we are talking about the electron. Okay, and what do you think, whether should electron has higher acceleration than proton, or should have, or electron should have less acceleration than proton? คุณคิดว่าเมื่อแรงที่กระทำบนอนุภาคมันเท่ากันนะเพราะมันสนที่ประจุใช่ไหมแรงสนามแม่เหล็กมันสนที่ประจุมันไม่สนมวลไม่สนอะไรเลยนะครับใช่ไหมมันสนที่ประจุกับความแรงสนามแม่เหล็กในเมื่อความแรงสนามแม่เหล็กเท่ากันมันสนความเร็วอนุภาคก็สมมุติว่าเท่ากันด้วยนะครับแล้วก็มุมที่ทำระหว่างสนามแม่เหล็กและกับสนามแม่เหล็กกับความเร็วทิศทางการเคลื่อนที่เท่ากันด้วยแรงมันเท่ากันครับแล้วคุณคิดว่าความเร่งที่อนุภาคทั้งสองจะมีอันไหนมันจะมากกว่ากันช่วยตอบผมหน่อยครับพิมพ์มาใน YouTube ก็ได้หรือว่าพิมพ์มาทางแชทใน Zoom ก็ได้ครับผมจะลองฟังความคิดเห็นคุณว่าคุณเข้าใจขนาดไหนนะโอเค because we are not in the actual room. Okay, this is not the actual classroom, so I cannot see you properly. So I would like to ask you, okay, whether you understand or not. นะครับเป็นไปได้ไหมครับตอบได้ไหมเอ่ยว่าในกรณีไหนมันน่าจะมีความเร่งมากกว่ากัน Any idea about that? Okay, do you have any idea which one should have more acceleration นะครับแรงกระทำบนวัตถุนะครับมวลไม่เท่ากันแรงขนาดแรงกระทำเท่ากันแต่มวลของวัตถุมันไม่เท่ากันโอเคไหมครับของที่หนักกว่าก็ควรจะมีอะไรของที่มีมวลมากกว่าก็ควรที่จะมีความเร่งน้อยกว่าใช่ไหมครับนั่นคือโปรตอนมีมวลมากกว่ามันก็ต้องเร่งน้อยกว่านะครับได้ค่านี้นะครับ 1.659 times 10 to 15 meter per second square ของที่มวลน้อยกว่านะครับได้แก่อิเล็กตรอนนะครับความเร่งมันก็ควรจะเป็นไงความเร่งก็ควรจะมากกว่าค่านี้โอเค let's talk about the acceleration for electron in this scenario. Here we have acceleration for proton, right? Now we are talking about the acceleration for electron. It's again the same value of magnetic force induced magnetic force. It's 2.77 times 10 raised to the negative 19. Okay, negative 19 in Newton. Okay, divided by the mass of electron. Mass of electron is no longer 1.67 10 raised to negative 27, but rather m electron is 9.11 times 10 raised to negative 31 kilogram. Okay, like this. So we have to use that value, which is 9.11 ไม่ตกขอบหรือเปล่าครับตัวนี้ไม่ตกขอบนะพอมองเห็นนะครับไม่ตกขอบนะครับ 9.11 times 10 raised to the negative 31 okay kilogram, and you will get the result from the calculator, electronic calculator again, this one, okay, by using this one. หรือว่าคุณจะใช้มือก็ได้ or you can calculate by hand, but it's quite tidy. Okay, it requires a lot of burden. Division of 2 digits, the number with 2 decimal digits. So after using the calculator, we're gonna get the result like this. the acceleration is 3042. Okay, 3r.042 times 10 raised to the power 18. Okay, power 18 and meter per second square. Okay, and that's it for the acceleration that can happen to electron. Okay, you can see that 10 raised to the power of 18 is greater than 10 with the power of 15. Okay, the object, the particle, which has less mass, is going to have higher acceleration, have more acceleration than the particle that has more mass. Okay, so that's the particle that's heavier. Okay, so that's the end of this example. Now let's go to the next example. I have to bring you to the lecture notes, right? The screen, the monitor. For the people in YouTube.
What's going on? Okay. There. Okay, we have completed this example. Okay, this one. Okay. Now the direction of the magnetic force is along the negative z-axis here. Okay, and the value of electron acceleration is going to be greater than that than that with proton. Now let's move to the next example. We are talking about an experiment, okay, in a physics lab. In a physics lab. คุณครูจอยไม่อยู่ ถ้าคุณครูจอยอยู่ผมก็จะถามอยู่ว่าสรุปว่าคุณจะมีโอกาสได้ทำ lab หรือไม่อะไร Anyway, no problem. Even we cannot have a chance to do the experiment in laboratory. Okay, you know the lab is laboratory, right? But I think if you study any branch with science, you need to study physics, and you have to also spend time for physics laboratory. And here you wrap a glass rod, okay, with silk. This example is taken from the book number 3, example 22.1. If you want to see more detail, with this wrap, okay, with this tidy work, a tedious work, sorry, you will get a shot with 20 nanocoulomb only, okay, very, very little. And it's positive charge, okay, that take place on the glass, okay, in calculate. Okay, now our glass has a positive charge with 20 nanocoulomb, and calculate the force on the rod due to the Earth's magnetic field if you throw it with a horizontal velocity of 10 meters per second. 10 meters per second. How fast is this value? 10 เมตรต่อวินาทีคิดเป็นกี่กิโลเมตรครับคนไหนตอบได้บ้าง Any idea of that? 10 เมตรต่อวินาทีเป็นกี่กิโลเมตรต่อชั่วโมงครับจะได้พอรับทราบในความเป็นจริงเขาคว้างไปได้ความเร็วขนาดไหนมันเร็วเท่าลูกเทนนิสที่ คุณเคยดูเขาตีเทนนิสใช่ไหมครับเขาจะมีสปีดบอกลูกเทนนิสใช่ไหมอืมนั่นนะครับ ก็ อืม มันเร็วขนาดไหน10 meter per second the way to do that is you have to multiply with 3000 right uh, 3600 and divided by 1000 right so it's finally it's 3.6 so it should be 36 kilometer per hour right 36 kilometer per hour let me check whether this idea is correct or not is that whether this idea is alright or not yeah. 10 meter per second to kilometer per hour so yes okay you multiply it by 3600 and divided by 1000 okay because we want to convert that amount into kilometer so it's going to be the multiplication by 3.6 so 10 meter per second is equal to 3.6 I'm not sure whether the people in Zoom can realize that okay I will share the screen right okay for the people in Zoom okay I use the website okay to convert any value in meter per second to the common sense in velocity which is kilometer per hour here you can see that it's only multiplication by 3.6 to get 36 kilometer per second so it's not fast it's not very fast as same as what you can see in the tennis tournament right moment your elder colleague รุ่นพี่คุณนะครับแกมาถามผมว่าทรงแบบนี้ได้ไหมจะตอบเขาสักนิดหนึ่งครับ okay and that's the way to find anyway we have to I have to share the monitor right? แชร์หน้าจอไม่มีปุ่มให้กดเลยเหรอโอเค here sorry for I get to share the monitor to you right. โอเคครับตอบรุ่นพี่คนนิดนึงอันนี้แก้ศูนย์ได้ไหมครับ Okay, sorry for that. เขาใจร้อนครับเขาจะอยากทราบคำตอบทันทีว่าแก้ได้หรือไม่ได้คือผมสอนคุณอยู่มันทำไม่ได้นะครับโอเคไหม sorry for that. So let's talk about it. Unfortunately, they throw the rabbit rod, okay, glass rod, along the west, okay, along the west direction. Okay, that's the problem we have listed. Is there any figure for that? No, there's no figure at all. In we will talk about the detail of this problem, right? So we get back to the. Let's move to the whiteboard again, and I think that we are going to. We should be able to complete or finish this example. It's not so complicated.
Okay. Okay, fine. This one is already finished. นะครับ is the assignment today. Okay, so the assignment today would be the request to you, okay, to find any problem related to this story, the magnetic field that is induced, okay, when you have a shard moving in a magnetic field area. Okay, according to this problem, everything is all right. I hope that the voice is okay, camera is there, and for the people in Zoom, okay, voice is all right. เหลือไม่กี่คนแล้วครับ ที่ซูมนะครับ okay, the voice is okay. In this example, we have 20 nanocoulomb charge, okay, positive charge, moving due west, okay, horizontal velocity along this way, okay, this is west, or sorry, this is east, this is west, 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 okay, and the velocity here is 10 meter per second, right, meter per second to the left. And what else? There is magnetic field on Earth, right? Which is, what do you think? What should the direction of Earth's magnetic field be? คิดว่าสนามแม่เหล็กของโลกมันจะต้องชี้ไปไง อันนี้ที่ตะวันตกใช่ไหมครับ so this is the west and here is the north, right? If we consider the map, and here is the south. Yeah, oh, sorry. South, okay, and here is the east. Okay, so what do you think then? The magnetic field should lie into this configuration for the 2D plane. So the magnetic field should be in this way, right? Magnetic field from south to north, right? This is Earth. Earth magnetic field. Okay, and they ask us what should the magnetic force be. What should the magnetic force be in this scenario? Of course, this is vector v, right? This is vector v, this is vector b. Okay, from v to b, right? From v to b, okay, you use your forefinger. V is in this direction and b is from south to north, right? This one, you curve your forefinger from v to b, you get, okay, the time direction in this way, okay, pointing into the whiteboard. Okay, it means the force is going to be in this way, okay, through the whiteboard, into the whiteboard. Okay, that's the first thing. Okay, you use this formula v to b. Okay, you curl your finger from the first vector v to b. Okay, v to b, so you get the force in this way, okay, from the right hand. And for the magnitude, unfortunately the time is over. Okay, we will talk about the magnitude of the force in this scenario later, tomorrow, right? Tomorrow on Saturday we have to meet. We are going to have this class again, the physics class. So again, the assignment is the request for you to find any problem related to this formula. Okay, choose anything, any book that I have provided in the classroom folder. I think on the very early days I have provided textbook. If you have any question, just let me know. มีคำถามไหมครับ ถ้าคุณมีคำถามเปิดไมค์ถามนี้พิมพ์มาเลยก็ได้นะครับหรือว่าถามไลน์ทักไลน์ส่วนตัวก็ได้ If you don't have any question, then we need to complete our lecture right now. Okay. See you tomorrow morning again. Bye bye ครับ สวัสดีครับ บ๊ายบายนะครับ สวัสดีครับ บายครับ